接下来我们邀请到的是微软高效能运算事业部前端暨云端应用平台总监 Doug Berger 为我们发表微软对极限运算的研究与观察。Ladies and gentlemen, next, Microsoft Director of Client and Cloud Applications, Mr. Doug Berger, will talk about Microsoft Research, Trends and Technology Directions. Please help me welcome Mr. Doug Berger. 热烈掌声欢迎 Mr. Doug Berger.
Thank you for the warm introduction. It is a real pleasure to be here visiting Taiwan. I'd like to thank Davis, Jane, Adnan, and the rest of the OEM and ODM team for the invitation to be here and speak to you all today. So I direct the Cloud and Client Applications division in the Extreme Computing Group within Microsoft Research. The charter of my division is to redefine how people are going to use computing in the future as technologies change. What are the new ways in which we will compute and leverage information technology to make our lives better, more enjoyable, and more productive? As we define and predict how people use computing, we build out the experiences, the software, hardware prototypes, and even silicon functionality to support our prototypes with the hope of eventually disseminating these ideas elsewhere in the company and to our partner ecosystem. I should note here before I start that everything I'm going to talk today to you about today is about research, trying to envision the future and make the future happen. Nothing I disclose in this talk has anything whatsoever to do with Microsoft product or product planning or product intentions, although of course our group hopes to have long-term influence. So with that caveat, let me start with the menu. There we go. So change is coming. Change is a natural condition of our ecosystem, given the pace at which technology moves, whether you're in a hardware company or a software company or an industry disrupted by information technology, such as magazines and newspapers and the music industry. But aspects of our ecosystem have been actually stable for a very long time, and many of those aspects are about to undergo transformative change. So in this rapid change that's coming, which will affect you, all of you in this room, it will affect me, it will affect other people in our industry, there is enormous opportunity to capture these changes, benefit from them, provide new services, conquer new markets. But alongside this wonderful opportunity, there is also danger. The danger of disruptive change and the danger of a shrinking in aspects of the information technology industry. So in this talk, I'm going to first talk about the opportunities that I see with new models of computing, and then I will talk about some of the dangers that may prevent us from reaching many of those new models and growing our industry and growing our ecosystem and providing increased benefit to consumers and businesses. So in this slide, I've divided eras of computing into 4 waves. These are all well-known waves, and certainly there are many different ways of looking at the history of computing. And so this is not a definitive partitioning, but it's just one take on it. We started, from the early 60s through the 70s and 80s in a mainframe era where computing was centralized, and then moved to an era of personal computing and starting in the early 80s and going through the next few decades. And I call those the first wave and the second wave. And then starting with the emergence of the internet in the late 90s, a third wave of computing came when personal computers and mainframes became networked, and they had access to much more information than was on their hard drives. And then the emergence of the mobile era, or the fourth wave of computing, allowed us to access many of these services and all of this information without sitting tethered to a computer. We carried it around with us in our pockets, which was really a profound change. Now, I should point out that through these waves of computing, a new wave doesn't kill the old one or displace it, it just adds to it and it grows the industry. So for example, when you do a banking transaction, you're still likely using a mainframe computer, perhaps indirectly. And we still all have PCs that we use for stationary computing, and we still use internet and web services on those stationary computers, but we also have these mobile phones in our pocket. And so I spent a good amount of time with my team thinking very, very deeply about what some possible next waves might be. And the one that we decided to invest resources in was a wave that I call continuous computing, or an era of continuous computation and services. And so what this continuous computing era, or this fifth wave of computing, will look like is it will incorporate increasingly natural interfaces to reduce the friction of computing. You'll hear me talk about it a little bit more later. There will be much tighter integration of computation with you, and there will be rich cloud services that will back all of that continuous computing capability. And these are services that will be running continuously in the cloud, gathering information on your behalf, trying to build services that will make your life better, do things anticipatorily, predict when you're going to need a service or some information and provide it to you, to really reduce the effort required to initiate some services and launch them. So let me go next into a little bit more of a discussion or a framework of what continuous computing might look like. So if I look at this graph here, and this is an abstract graph, if I think about, the x-axis is time spent invoking a computer service or using it to do something on my behalf. And the y-axis might be the utility of computing. How much benefit do I get from invoking that service? I can then have a graph here which says, for the utility of using a service, how much time do I have to spend at that service? So if I think about the old mainframe model, I might be in a situation where I have to, if we go back to the 60s, where I have to create a card deck of punch cards and wheel it into a room and feed it into the machine and batch it overnight and wait for the result the next day. Okay, that's the old model, and that is a very large chunk of time, but obviously I get a fair amount of utility out of that. And if you think about this graph abstractly, there are times when I don't need very much information technology service. Perhaps if I'm in the shower or playing with my children. Or actually, I can think of times when information technology will be helpful with my children, so ignore that. So now if we then think about trying to reduce the time you spent to invoke a service, I can go to something that looks like a mobile scenario where I use information technology services much more often, and there are times when they're incredibly useful. I'm late for a meeting and I don't know how to get there. Show me the direction because my boss is waiting with some outside partners and I'm going to be 10 minutes late. That's a really important use of information technology. And then there are times when it's less important. But the effort to use it decreases as we move to more and more natural modes of interaction. So in the limit, and of course I think you all can think of this from a calculus perspective, in the limit, what I'm doing is discretizing a continuous function. And what we're doing is sampling from information technology and internet services more and more frequently with a lighter and lighter touch. And so an example is, if I can do this without knocking off my microphone, every time I reach into my pocket and pull out my Windows phone and use a service and then put it back in some sense that's a sampling point of this continuous function. And what I've observed is, for my wife and for others, they're sampling at a faster and faster rate. Facebook feeds come in and they want to check and see the latest thing. It vibrates in their pocket and they check it. And I'm worried that my wife is going to start getting tendinitis because she's starting to sample so fast. So I think what this indicates to me is that there's a desire to move to a model where computing is continuous. We're always using it. We're always getting services. We may not choose to use them. We don't want to be interrupted constantly. But there are potential models out there that will allow us to continuously produce and consume content and reduce the time spent invoking services at a finer and finer granularity. So that's one direction that we can see computing going and providing qualitatively new and qualitatively better experiences for consumers. So what are the requirements of continuous computing? Well, first, it has to be very low friction. If I have to generate a slide deck of punch cards to invoke a service, I'm not going to do it very often. So we want to bring the friction of using a service down. Pulling my phone out of my pocket is much lower friction than driving home to use my stationary personal computer. But the friction is still too high. There are times when I want to know the answer to a question quickly. I don't want to pull my phone out of my pocket, unlock it, type in my password, pull up a browser, type in the URL, get a list of candidates, push one of them, wait 5 seconds, see that it wasn't the right page, go back, push the next one, have it come up, read the page, resize it continuously to align the text, and finally find the information I'm looking for. That is not low friction, but it's convenient because the phone is always with you. So we have to bring the friction of using those operations down considerably. Next, it has to be always available. Wherever I go, I have to provide form factors that I can wear almost all the time to use them continuously. Third, it needs to be context aware. So we want rich packages of sensors monitoring our environment and figuring out when I need the service, when should I download something in advance to anticipate that I need it. Because context is incredibly important for figuring out what services you need and what you should be doing. Fourth, it should be personalized. Everybody's requirements are different, and so the models that sit in the cloud and build these services and anticipate your needs should be models that are tuned to you and not to your cousin or your spouse or your family. So these services need to be all about you. And finally, and this is debatable, but I have my position on this, these services need to be private. Because as things become more and more personalized and more continuous, much of that information is incredibly sensitive and information that I would not want companies to have. And so as we move further and further into this domain, privacy, which has been eroding steadily, needs to be strengthened and reinforced and provided to consumers. Otherwise, the concerns that people have about their private data being spread all over the internet will prevent these services from being widely adopted, therefore limiting their commercial success. Okay, so what are the components of continuous computing? I've mentioned a few of them. They are things like voice, what expressions are on your face, what is the charge on your skin, your galvanic skin response, what do sensors tell you about your gait, how are you touching different objects, what is your context, are you inside, are you outside, what were your last 5 searches, what gestures are you making, what tasks might you have to do, what tasks are due in your Outlook calendar. All of this information can be brought together and mined and applied to models about you that will learn continuously over time to produce the context necessary to serve you what you need continuously. So in this talk, I'm not going to talk about many of the things that we're working on for the interfaces that will provide some of that continuous computing, and I won't talk about some of the services that we're prototyping, or all of them. I will talk about a few, but I think you can imagine some interfaces that